This induction motor is a 1 horsepower, 2-pole, 240 volt motor operating at 60 Hz, and the rotor is rotating at a speed which generates a slip of 0.036. After stator winding resistance measurements, no load testing, and locked rotor testing, the equivalent circuit looks like this. The equivalent circuit values are shown here for both the forward rotating field circuit and the backward rotating field circuit. You can see them on this slide. Our task in this problem will be to calculate the total impedance of the forward equivalent circuit, we'll call it ZF, the total impedance of the backward equivalent circuit, ZB, and the total motor circuit impedance, ZT. In order to find the impedance of the forward equivalent circuit, we only need to concentrate on that circuit, which is made up of 3 impedances in series which are in parallel with 1 reactance. The forward impedance, ZF, is equal to 1.6 divided by 2 plus J 8.7 divided by 2 plus 4.43 divided by 2S, which is in parallel with J 63.2 divided by 2. Working out the series parallel combination, we get 62.4 times 31.6 divided by 62.2 plus J 4.34 plus J 31.6. Keeping in mind that we are working with phasors or vectors, we must follow the rules for phasor arithmetic. We get 12.5 plus J 24.67 ohms in rectangular coordinates, or 27.656 at an angle of 63.13 ohm degrees in polar coordinates. In order to find the impedance of the backward equivalent circuit, once again, we only need to concentrate on that circuit. The backward impedance, ZB, is also made up of 3 impedances in series that are in parallel with 1 reactance. 1.6 divided by 2 plus J 8.7 divided by 2 plus 4.43 divided by 2 times the quantity 2 minus S, which is in parallel with J 63.2 divided by 2. Working out the series parallel combination, we get 4.75 times 31.6 divided by 1.93 plus J 4.34 plus J 31.6. Keeping in mind that we are working with the rules for phasor arithmetic, we finally get 1.49 plus J 3.89 ohms in rectangular coordinates, or 4.17 at an angle of 69.04 ohm degrees in polar coordinates. Finally, we are tasked with calculating the total motor impedance, which is the sum of the forward impedance ZF in series with the backward impedance ZB, which in real terms is 12.05 plus J 24.67 plus 1.49 plus J 3.89, which adds up to 13.54 plus J 28.56 ohms in rectangular coordinates, or 31.61 at an angle of 64.63 degrees in polar coordinates. We have now completed the tasks that we set out to complete, so we are done. Ready to go beyond just solving problems? If you've been following my daily post and enjoying the sample problems, you're going to love this. All of these problem sets and more are now available, or soon will be, on my official course site. My stands for electrical training. Just go to the web address that you see at the bottom of this slide, https://stand.store/GVB.